Greetings, today we are going to be learning about physics.
Physics? So like velocity and stuff?
Yeah. That's so boring. Whoa, did you just say it was boring? Physics is far from boring.
Prove it. Oh, I will prove it to you.
To target!
But you can't drive a car. Neither can I. Well, granted, we are the same person, just moving around to make it look like we have friends.
This car's just for show. We can use the power of editing. Editing! Do the thing!
I got you!
Anthony, where did you go?
Editing, do the thing for me!
See, I would, but I kind of have to use the bathroom, you know. The Wiz Palace, the John, the Lou, where I do my business.
Mystical editing powers.
Thanks, editing.
So now that we're at Target, let's talk about speed. Wow, Anthony, we already knew that. Ugh, you're so annoying. Well, anyway, speed is expressed in distance over time. So if I ran 6 meters in 2 seconds,
I sure am home.
Then my speed is 3 meters per second.
Isn't velocity speed?
Wrong, velocity is speed pertaining to a certain distance.
But what direction? Up, down, left, right, north, south, east, west, northwest?
For instance, if I was traveling 4 meters per second to the right, and 4 meters per second to the left, then I would have the same speed but different velocities. Now we'll talk about the laws of motion.
Motion has to live by laws?
Sorta. There are 3 laws of motion. Let's start with the first. The first law of motion states that an object in motion wants to stay in motion unless acted on by an unbalanced force. And an object in rest wants to stay in rest unless acted on by an unbalanced force.
But what's an unbalanced force?
An unbalanced force is a push or pull that changes the motion of an object. So if I push a cart, then I am applying an unbalanced force which is changing the motion of the object, making it no longer rest. The first law of motion is also called the law of inertia because inertia is the property that keeps an object in or out of motion. The more mass an object has, the more inertia it has. Now let's move on to the second law of motion. The second law of motion states that an object's force depends on its acceleration and mass. The law revolves around the formula F equals am, which is force equals acceleration times mass. To find the acceleration of an object, you divide the force over the mass, and to find the mass, you divide the force over the acceleration.
But Anthony, what happens when the force, acceleration, or mass changes?
Well, let's take a look at the cart. The cart will go faster if there's nothing in it. But if you add 120 pounds, there is less acceleration. So as there is more mass, more force needs to be applied to maintain the same acceleration. Lastly, the third law of motion. The third law of motion states that every action force has an equal and opposite reaction force. So if you run into something, the reaction will you be forced back. Roll the clip.
Oh, it's like the fence pushed me back. It was amazing. Let's do it again. Then why doesn't the ground move, huh? I got you there.
Pillow.
Pillow? God, you don't have to be so forceful.
The ground doesn't move because of the first law of motion. The Earth has a lot more mass than us, so it doesn't move because it has a lot of inertia.
Anthony, why did the cart stop?
That's because I stopped applying force,
But why didn't the cart just keep moving?
because friction stopped the cart.
Oh, frick my shins.
Friction is the force that resists motion.
Isn't that inertia?
No, inertia is a property, while friction is an actual force.
What's the difference?
A force is a push or a pull, and inertia doesn't push or pull. Okay, editing, back to the house.
I got you!
Mystical editing powers.
Thanks, editing. Oh, we're at the swings. Okay, let's take this time to talk about gravity. What, Anthony, number 1? What's gravity?
Good question. Gravity is a force that brings all objects together due to attractions. Attractions.
attractions, Anthony. You're 14. What's next? Laughing at the word butt? Butt. Okay then. Gravity depends on mass. So the more mass you have, the more gravitational force you have. And since everything has mass, everything has gravitational force. But Anthony, then how come I can't feel the gravitational force of this swing? Because the gravitational force is so small that we can't feel it because it's insignificant. Anthony, how does energy relate to all this? Good question. Energy is the ability to do work. So we use energy for everything. Let's take a look at this swing, for example. Woo! I'm living. Whoa. 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 Achoo!
Uh-oh. Hopefully that didn't do anything.
Mystical editing
How
powers!
did I get here?
But you can't drive a car, you're too young.
You're too young. Don't do drugs. Don't get pregnant. Don't, no.
I got you.
Oh, that was a failure.
Achoo! Oh my lord. Just kind of... Achoo! Uh-oh. Hopefully I didn't do anything. Achoo! Oh, nope, messed up.
Greetings, today we are going to... I messed up.
Dodge.
No.
Yeah.
Isn't Philot... Wait, can you see this? Can you see the paper? Pillow? Pillow? Pillow?
Wait, you gotta move your
Pillow?
arm.
Wait.
Now-
Did you get that?
Yeah.
Okay, I'm sorry, you actually have to aim. Okay. Go.